In the previous section, we looked at special cases for trinomials and binomials. In this section, we also look at special cases for binomials, but these are what we call sum or difference of cubes because the degree is 3 for both cases. And they're binomials because they only contain two terms. See, just a cubed plus b cubed, a cubed minus b cubed. So this is the reason why we call it a difference, sum or difference of cubes. And keep in mind that these are binomial cubes. So this is like a cubic binomials. So when you have a sum of two terms cube, they can be factored into a plus b times a squared minus ab plus b squared. And when it's a cubed minus b cubed, then you put into a minus b times a squared plus ab plus b squared. So that's the factoring formula. So make sure you memorize these. Let's apply that to some of these problems. So say if we had x cubed plus 8 and we want to factor this, then notice that this falls under this special formula. So it becomes, the first thing we'll do is we'll write it as x cubed minus 2 cubed because 8 is really 2 cubed. So your a is x and your b is 2. And then this becomes, notice that falls under this formula. So this becomes a minus b, so a minus b followed by a squared plus ab, so ab plus b squared, so b squared, and there you go. So you just factored your first difference of cubes plus 4, and then we turn that into 4 just because it looks nicer. Okay, awesome. Let's move on to the second one. B to the 6 plus 125. So this is a sum, so we use the first formula, and we need to turn it into powers of 3. Now b to the 6 can be rewritten as b squared raised to the power of 3. That's b to the 6. And then the 125 is really 5 to the third power. That's how you get to 125. So it resembles the first case, and then you identify your a. This is your a, and then this is your b. Okay? And then the formula says a plus b. So a plus b, right? That's your a, that's your b. And then it follows with a squared. So this is a, and then you square it. So a squared. See? Minus ab. Minus ab. ab. So this is your a, and that's your b. Plus b squared. So plus b squared. And there you go. Differences of cubes. I'm sorry, sum of cubes. Let's try this guy. So I guess in order to use the formula, make sure you can rewrite the problem as something cube, and then you apply one of these two formulas. Now there are problems that might be easier than others, and remember that we start every problem by looking for a common factor before we proceed, and that's example number 3. Looking at example number 3, I can take out a 2m squared. So take out a 2m squared, and I'm left with m to the third plus 1. Take out 2m squared, you get m to the third plus 1 because that's what they have in common. So looking inside this bracket, you notice that this is actually sum of cubes because the first term is raised to the third power, and so is the second term. So 1 is also 1 raised to the third, which resembles the first formula right over here. Our a is going to be m, our b is going to be 1. So a and our b. Okay, and according to the formula, it's a plus b. So m plus 1 followed by m squared minus ab plus b squared, and b squared is also that. So there you go. Number 4. Number 4, this is a sum, so it's very likely that it will resemble this formula. Are there any common factors, or is there a common factor between the first and the second term? And the answer is no. So if you have x raised to the 6, you can always write it as x to the second to the third, because that's how you express x to the 6th. 3 times 2 is 6. And then earlier you learned that 125 is 5 to the third power. So technically, since y also gets raised to the third power, we can combine them together so that they look like that for the second term. This is your a, that's your b. So then you have a plus b, so a plus b, and that's part of the formula, a plus b. And then follow with like a trinomial, but this guy's a squared. Okay, so keep that in mind. So a squared, so times a squared, so a, and then you have to square it, minus ab, where's your a? Your a is x squared, your b is 5. Okay, plus b squared, so b squared. So that's your last term. And then what you want to do is you want to clean this up a little bit so that it becomes x to the 4th minus 5x squared y plus 25y to the second power, and you're done. So what we've done is we looked at the strategies for sum and differences of cubes, and now the last thing we want to do is we want to incorporate all these strategies together. So when given a problem and you're asked to factor this problem, then what you want to do is you want to follow these 3 strategies, these 3 steps. The first step is to try to look for the greatest common factor and pull that out. Once the greatest common factor has been factored out, then if you see 2 terms inside the parentheses, then try factoring as a difference of 2 squares. If you see 3 terms, maybe use grouping or use the Xbox method. If you see 4 or more terms, then try grouping, factor by grouping, and factor out a common binomial factor. And then always factor completely. In other words, you factor so that it's not possible to factor any further, and that's what we mean by factoring completely. Write the complete factorization and check by multiplying. So there's a lot of things going on, but here's the basic. So when you see a problem, see if you can pull out a common factor. If you see 2 terms, then see if is it a differences of squares or differences of cubes. If you see 3 terms, try to use that Xbox method that we discussed about. If you see 4 terms, then try factor by grouping. And always factor completely. Write your final answer in a complete factorization. Alright, so let me walk you through the first problem applying all these steps. I encounter my first problem. The first thing I do is I try to see if they have any greatest common factor. So between the first term and the second term, I noticed that they have a 9 in common, and they also have 8 y's in common. So I will then pull out 9y to the 8. This left me with 2y minus 3 inside. I'm left with 2 terms inside. And so I check, are they differences of squares? They're not. Nor cube. So they're none of the above, so I don't need to go to look at these sub terms right here. I just jump directly to D, write the complete factorization and check by multiplying. So that's the best I can do. I'm done. Technically, I'm done. Number 2. Do they have anything in common? The greatest common factor. They don't have anything in common. So that's part A. I'll move on to part B. It's 2 terms. Are they differences of squares or differences of cubes? So when I look at this, I notice that they're differences of cubes because they can be rewritten as m squared to the third power minus 1 to the third power, so they're differences of cubes. And that means that my a is m squared and my b is 1. And according to the formula, then I have a minus b, so a minus b. And that follows by a squared plus ab plus b squared Now, if you look over here to the first parentheses, you notice that this is once again two terms. So it turns out that there are differences of squares. So that means that we can further factor them into m plus 1 and minus 1 for that guy. And that's what we mean by factoring completely for this problem. Okay, let's take a look at number 3. This is a trinomial. The first thing I do is I look to see if they have anything in common. Do these three terms have anything in common? They have a 2 in common. So take out a 2, and that leaves me with this, okay? Now this is a trinomial, so I'm gonna try to factor by the Xbox method, but because the leading coefficient is not a 1, my Xbox method will have the number 12 on top because that comes from 6 times 2, that's 12. And then negative 7 goes down here. And I'm looking for two numbers, and those two numbers are those two numbers. So I go over here, and then what I do is I replace the middle term. So replace the middle term. So that's one of the reasons why the part of the strategy says factor by grouping, because after you do the Xbox, you're going to be factoring by grouping. And so in here, I group the first two terms, which allows me to take out a 2x. When I group the last two terms, I can take out a negative 3. And the reason why I wanted to take out negative 3 is because I want the parentheses to look the same. So inside this bracket, we can factor this expression as x minus 2 because that's what they have in common, followed by 2x minus 3, and then we bring this 2 down and we're done. Now if you have questions on how I went from this line to that line, I will refer you back to, I think it was, I believe 5.3 lesson where I show you how to factor something like this. So look over that video lesson to know how I went from here to here. So this is the last problem, and this problem is a little bit more difficult than the one before. This is a 4-term polynomial, and what we do is we have to factor by grouping. Now usually we group 2, but in this last problem we actually have to group 3 terms together. So we're going to group these 3 terms together. And then leave the 4b to the 4th over here. Now these 3 terms, maybe you will notice that this is a special trinomial, so they can be factored into m plus 7 squared because of the way how they are written. And then minus 4b to the 4th. Now, because the first term got squared, so we consider this as just one term. So this is the first term. The second term, we can also write that as something squared. So 4 is really 2 squared, and b to the 4th is b squared squared. So technically the second term is also written as something squared, and this falls under the difference of squares, which means that you can factor it into a plus b. So this is your a, this is your a plus, this is your b, followed by a minus b, so a minus b. Okay. And you're done.